everyone. My name is Shiyu Chen, and I am a data solutions engineer at Atorus Research. Today, I'm going to be sharing our new package, sdtm.oak, that is designed for sdtm programming in R. This package has its roots in the oak package that was originally developed by Roche for their internal sdtm automation. And as a member of the team who supports their internal sdtm workflow, we realized the potential of this tool and decided to take this concept and make it an open source version for broader use. So in this presentation, I will start by exploring some of the common challenges that are encountered in the implementation and management of sdtm at the industry level. Realizing these challenges is crucial because it underscores the needs for an innovative solution. And then we will dive into sdtm.oak, our new package that was designed to tackle some of these challenges. I will give a brief introduction to the package, including its purpose and key features, and we will explore what has been open sourced by Roche. The core concept behind this package is reusable algorithms, so I will explain what that is and how it can streamline your sdtm workflow. And I will give you a walkthrough of the programming steps and also give you a code walkthrough to give you a better understanding of its functionality. Then I will cover the details of this release. We'll also look ahead to the future of sdtm automation through open source contributions, outlining our approach and how you can get involved in this exciting journey. So the common challenges that are encountered at industry level can be categorized into two main aspects. The first one is raw data structure. Different EDC systems actually produce data in different structures, different variable names, and dataset names. Even though you're using the same ECRF forms, the extracted data from different EDC systems can still differ due to the addition of the system-specific variables and the other elements that were collected on top of the collected data. And secondly, from a standards perspective, although CDASH is available and it provides a framework, companies can still develop varying ECRFs using the CDASH standards. So with these many impacting factors, it might seem daunting to come up with a common solution for sdtm programming. And our package sdtm.oak attempted to overcome this problem by providing an EDC-agnostic and standards-agnostic solution, aiming to provide a more universal approach to sdtm automation. The package is sponsored by COSA and many top pharma companies and also many more independent volunteers. It is part of the Pharmaverse group of our packages, and it is included in the Pharmaverse project on GitHub. With inspiration from Roche's oak package, sdtm.oak is an EDC-agnostic and standards-agnostic solution, and it provides a framework for modular programming of sdtm in R. And this idea can be further extended to automate sdtm datasets based upon the metadata-driven standard sdtm specifications and control terminologies. And we will also pilot the same approach using the standard C-ECRFs in the CDISC library as we advance its development. The core concept behind this package is reusable algorithms. So what we are trying to open source is actually not the source code from our oak package, because our oak was developed specifically for Roche studies. But the core concept is reusable. Roche has developed 22 algorithms to automate 13,000 sdtm mappings across 6 different therapeutic areas, and each algorithm is programmed as an R function in our oak. So we have taken these functions and see what could be applicable to the open source world, and then we reprogram these functions to make them EDC and standards agnostic so that any company can use it. This is a high-level overview of different mapping algorithms. Assign-no-CT is a mapping algorithm that can be used to do one-to-one mapping from the collected value to the target sdtm variable, with no control terminologies associated. We then program this algorithm into an R function, and this function could be interchangeably used across these different domains to populate different variables. Similarly, we have other algorithms like assign CT, hardcode CT, hardcode no CT, and also another very useful algorithm called condition add. This algorithm conditionally checks a specific criteria before performing the mapping. So these algorithms can be used across different sdtm domains, and these are actually language agnostic. So we have chosen to implement them in R because firstly, oak was developed in R, and also many other Farmaverse packages were developed in R. However, they are technically language agnostic, so you can use any programming language to implement them. And this is also automation ready. This is actually one step towards the full automation. These algorithms can be pre-specified for data collection standards within the metadata repository, and once specified, they can be used to automate sdtm whenever the standard ECFs from your metadata repository are utilized in a study. This methodology is currently implemented at Roche, and we will pilot the same approach with CDISC library as we advance its development. So this is a sample screenshot of how CMTRT is mapped. CMTRT is a topic variable, so we choose to use, and it has no control terminologies associated, so we can choose to use the assign-no-CT function. In this function, we pass the raw dataset name, raw variable name, and target variable name in it. And by running this function, it creates the topic variable CMTRT for us. Similarly, we can generate the other variables using the same function as long as they share the same concept and you assign those arguments correctly. This is how we made it EDC-agnostic. As long as you have the arguments defined in a function, you should be able to do any mappings using this function. On the screenshot to your right, you can see that we firstly map the topic variable, and then we derive the other variables like qualifiers and identifiers using the same function, and we connect them using the pipe operators. When we come to the code walkthrough, it will be more detailed and clear. The programming steps in sdtm.oak is very close to the key sdtm concepts, that is to map the topic variable first, and then map its qualifiers and identifiers that give additional information to the topic variable. And you repeat this process again and again for different topic variables in your source. These programming steps can be used across different domains like events, interventions, and findings, and the framework we have put together has a huge potential for full automation, similar to Roche's implementation. Moving on to the details of the programming steps. So the first step is to read in the raw datasets. The package processes one raw dataset at a time, and similar raw data sources can be stacked or merged together as a pre-step. So the raw datasets needs to be processed before being used in sdtm.oak. For example, if you have one form for vital signs in screening and another form for treatment phase, even though they were collected on two different ECRFs, they actually share similar information, so you can choose to either stack them or merge them together. And then we introduced this concept called oak ID vars. Oak ID vars is a group of variables that can be used as unique identifiers to uniquely identify each record in the raw dataset, and they will be used to merge the qualifiers to the topic variables. And then we need to read in the user prepared control terminologies file, either in CSV or Excel format. So these are the three required elements before we can use sdtm.oak to do the mapping. And then we can map the topic variable. The package usually processes one topic variable at a time, and we can choose the mapping algorithms that we want to use, such as assign CT, assign no CT. And then we can map the rest of the variables that give additional information to the specific topic variable, like qualifiers, identifiers, and timing. And similarly, we can choose the mapping algorithms we want to use. And we repeat the same process again and again for all the topic variables in the source, and we can map the qualifiers that are common to all the topic variables. And we also have functions for derivation variables like baseline flag and study day. And lastly, we can assign labels and attributes to the variables. So these are the generic steps that can be used for most of the domains. With this, I will give you a walkthrough of the package downside and also show you the package documentations as well as some code examples. This package has been released on CRAN, so you can follow the installation instructions on the homepage to install this package. You can also read through the package introduction here. And then we move on to this reference page. This page includes all of the functions we have developed and also the links to their documentations. We have developed functions for mapping algorithms, condition data frames, SDTM examples, control terminologies, date and time conversion, etc. And under this articles tab, there is one article for algorithms and sub-algorithms. It introduces a core concept, and it also lists all of the algorithms that we have developed or will be developed in the future. And it also lists the detailed description for each of the algorithms. Some of them can be used as sub-algorithms together with functions like condition add or dataset level. And then we can move on to this creating an events domain function page. Sorry. In this page, you can see that we've used CM domain as an example, and we have created some dummy datasets for the users to play around with. This programming workflow is similar to what I just showed you in the previous slides. And we also included code snippets for the users to try. In each step, there is also explanations for the mapping logic for each of the variable. Similarly, there is another article for the vital signs domain for findings domain, and we are using VS as an example. The programming workflow is very similar, and the user can read through it to get a better understanding of the steps. The structure of the documentation is actually very close to the Admiral documentation. So for those of you who are familiar with Admiral, you might find these pages very easy to follow and navigate. Then I will give you a code walkthrough using VS domain as an example. The first step is to read in the control terminologies file. In this user prepared input, we can see that it follows a standard format. Term code is the NCI codeless code from CDisk. Term value is the final SDTM standard values that we want to use in output. Collective value, term preferred term, and term synonyms are three different formats of input that we allow to be mapped to the standard term values. And then we need to read in the raw data set and generate the oak ID vars. The vs_raw data frame contains all of the information we need for this vital sign domain. And because we've created oak ID vars, there are 3 new variables being created. And these variables are used to identify unique record in the raw data. And we will use them to merge the qualifiers and identifiers later on. In this example, there are multiple topic variables like systolic blood pressure, diastolic blood pressure, etc. And in the template later, we will process these topic variables one by one. The next step is to read in the DM domain. And then we can start mapping the first variable, systolic blood pressure. By running the hardcode CT function in the subset, you can see that we have the topic variable test CD being created and the term value sysbp is entered. And then we can run the other functions that creates the qualifiers and identifiers and give additional information to systolic blood pressure. So in this final subset, you can see we have the other qualifiers like Atorus, Atorus-U, and position being created here. So we repeat the same process for the other topic variables like diastolic blood pressure, pulse. We can run until the last topic variable. With this, we have all of the subsets we need. And in each of this subset, the qualifiers and identifiers for the topic variables are also being created. So now we can bind these rows together. In this vs_combine, there's 31 observations in total. And as you can see, different test CD values are stacked together here. So now we can map qualifiers that are common to all the topic variables. We have developed this function called assign datetime. In this function, if you pass the raw data name, raw variable name, target variable name, and the raw format of the time variables, by running this function, it will return you the DTC variable in ISO 8601 format. So we can run all of the functions till the end. And as I mentioned before, we also have this derivation function developed for study day. So now we have our final VS domain. And that's all for the demo. We currently have our package version 0.1 released on CRAN, and we have programmed a few functions for mapping algorithms and also the required derivation functions like sequence number, study day, baseline flag. And as you just saw from the demo, we also have template programs available for CM domain and VS domain. So this package is able to program majority of the domains. However, it's not supporting the DM, RelRec, SE, SV, and TDDC yet. We are still in progress of making those functions. Our next step is a path towards the full SDTM automation. So we will prepare a standard SDTM specifications template where users can define the raw data source, target SDTM domain, target SDTM variables, and the algorithms that they want to use for automation. and we will make our package be able to read and process the specs and call the corresponding mapping functions automatically. We would also like to consider the possibility of using LLMs into our development to auto-generate our code based on prompts. In the future, it might look like this. On the left side of the screen, this is our current modular programming workflow. And as you could imagine, if you have multiple raw sources for a single sdtm domain, then your code could get lengthier and lengthier. So what we are thinking is that we can either try to use LLMs to auto-generate the repetitive code for you, or we can consider the option of creating one simple function call called create_domain, where you specify the specifications and control terminologies. And by running this function, it automatically call all the mapping and derivation functions based upon your specs. And it will just return you the final STM domain. What we are trying to focus next is firstly the functions for the DM domain. Because DM domain has many reference dates, we are in progress of making functions to calculate those dates. And after we hold the workshop and hackathon in the community, we will incorporate users' feedback into our development to better improve our package. And also, we will explore the pathways for code automation and also the metadata-driven unit conversions, and also the approaches to handle QS domain. So please feel free to try this package out and share your feedback with us either on Slack or on GitHub. We look forward to hearing from you as we continue with the development. Thank you for your time.